Hi, and welcome to a new project which I've been working on recently, which I find quite exciting because it's trying to get a keyboard working with Sonic Pi in order to produce input. And I've achieved something which works reasonably well. There's no changes at all to Sonic Pi. The program is simply put into a buffer, and we have a separate program which runs in a terminal which is used to pull a keyboard down here, just an ordinary QWERTY keyboard, and then send information from there up to Sonic Pi and cause various things to play. It works in two different modes. The first one is that I can actually poll for some single keys and use them to play individual notes. So if you look at this portion of the program, you can see that when a lowercase a is played, it's actually going to play a note C4, a W, and the row above on the keyboard is going to play a C sharp, an S, a D4, and so on all the way across to here. We've got roughly an octave and a half up to, if I scrolled the program across, we would see we get as far as a G, G5 at the top there. So that can be done. The tricky thing is actually getting the timing right without the Sonic Pi falling over, and I've had to actually use two linked loops together, and I've managed to adjust it so that it works okay without falling over at all. The second thing that we can actually do is to use other keys to emit some cues, to send some cues. So when I press 1 up to 0 on the keyboard, it's actually going to generate cues 1 up to cue 0. And this is quite exciting because we can have some pre-written bits of Sonic Pi code further down in some live loops down here. And you can see that these are fairly short, but each one has at the beginning of it a sync command. So this live loop will only start running when it receives Q2 from the main part of the program. And that is going to use the new loop tabler and play that. This one is going to play some notes using the pluck synthesizer. It's a guitar-like sound. This one is going to play some 4 whooshes using the new Cineboom sample, slightly mucked around with. This one is actually going to play some notes using the TB303 synthesizer. This one is actually going to play some music. It's going to play a 3-part round of Frere Jacques, and this one is going to play a fanfare, some 3-chord fanfares. This one is going to play a drum roll followed by a bass drum. This one is going to slide around some couple of notes. And the last one is going to go right through all the samples, apart from the loop ones, very fast. And so these can all be controlled simply by pressing keys 1 to 0 on the top row of the keyboard here, and we'll see that in operation in a minute. The heart of the program, uses a TCP socket. If I come up towards the top of the program again, here we are. The heart of the program uses a TCP socket, and it simply gets the input which is sent to the from the keyboard from the transmitting program, and it then parses what that is and causes the various action to take place. So we also need a separate little Ruby program. It's not very long. That's the whole thing there. Don't worry if you can't grab it all from now, because I'm going to publish all these and you'll be able to download them and try them yourself. And this uses a bit of fairly inscrutable code, which I actually found on the internet, which does the polling of the keyboard. And I simply added to that the TCP socket in the end, a transmission to send the information out to Sonic Pi. And so in order for this to work, we need to get rid of that, and we need to bring up a terminal, and we need to run the program in this terminal. It's called SB Control RB, and we need to have that running before we actually have Sonic Pi being utilised. Otherwise, if I run Sonic Pi, it'll just crash out because it'll say there's no socket open for it to listen to. So we start that running. You won't see anything happening there. We can now come over to Sonic Pi and we can start that running. Again, nothing happens, but it's now waiting for me to type something on the keyboard, which is down here. And hopefully what I type should appear up on the screen here. So if I start off by typing a lowercase a, like that, you can hear the C that it produces. Type an S, and there's a D, and it produces an E, F. Now the response time for single notes is a bit slow, but if I play several notes together, like this, we can actually get a much faster response, and we can actually play almost play chords by playing notes in quick sequence one after the other, like that. So that's the first mode that we've got to operate this in, which is quite exciting in its own right. But let's now look at the second one, and I'm going to press key 1, and you remember that that was going to play the loop amen break for us. So here we go. And there's loop amen starting off. When I press 2, that starts playing the tabla loop. 3 was going to play some plucked notes. 4, the whooshes, 4 of them. 5, TB303. 6, Frere Jacques. 7, followed by 8. 9, the sliding notes. And 0 goes right through all the samples very fast. And you can play these together. While that's playing, we can start the loop amen at the same time. And maybe start something else. Maybe play the fanfare on top of that. And play on the keyboard, the chord. Start that, play again. So, hope you enjoy the demonstration. You can see that it's fairly robust, nothing's fallen over. It works, this is working on a Pi 2 with an IQ audio amplifier in the top there, so it works on those. I've not tried it on Model B, I think it might fall over on that, but certainly a Pi 2 and a Pi 3 shouldn't be any problem. The only precaution I've taken is if I come right up to the very beginning of the program, before that I've got 2 bits of code. The first 2 lines there would actually wipe out any samples which are stored, but the second group of 3 lines there is simply going to go through and load all of the samples apart from the loop ones before we start, because it's not fast enough to keep up with loading them and playing them at the same time. On a Mac it's okay, you don't need that, but otherwise it works fine. And the only other thing I had to do is I had to actually change on the Pi very slightly the keyboard allocations, because the letters at this end of the keyboard, funny things like square brackets and hash signs, were slightly different on this keyboard here than on the Mac keyboard, which I've got here. And you can see that the allocations at the end of that row are slightly different, and so I had to amend the codes which we were looking for in order to get it to work on a Mac. But otherwise it works quite transparently between the two without any problems. Hope you've enjoyed it, and have a go doing it yourself.